The Lehman field is a giant gas field. It's very relevant for CCS because it's actually one of the biggest gas fields in the UK. It used to contain 14.5 TCF of natural gas, of which 80% have been produced. So we have a lot of space to store CO2.
Measurement, monitoring and verification is crucially important in CCS. It really helps us in two main ways.
So MMV helps to show that our models are correct and our predictions are feasible, but then secondly to demonstrate to the regulator and the public that what we're doing is safe and worthwhile.
It's important to know how much we can inject into the reservoir and be sure that there will be no leakage into 1,000 or more years.
When we reach the development phase, it's really important for us to have a tried and tested MMV program. So this testing phase here is a perfect opportunity for us to test the various technologies to see which ones are going to be more effective.
On the run-up to this injection test, we've done a large scouting exercise to look at which technologies are out there and mature enough to actually be able to help us. And those include things that are tried and tested in the oil and gas industry, but also this is a fantastic opportunity for new and upcoming technologies to test themselves out as well, such as Silixa and the DAS technology.
We will use more advanced technique than the ones that we are using in the oil and gas fields. But obviously, managing CO2 is more challenging. It's a complex gas that could be either liquid or gaseous, and that's changing phase during the injection, and this is very difficult to handle into the model.
Silixa has the best-in-class metrology for both its distributed temperature sensor and intelligent distributed acoustic sensor. This helps Perenco achieve their monitoring, measurement and verification goals both before, during and after injection.
So we've selected a vast array of technologies for this injection test to calibrate our models from pressure and temperature through to acoustics as well. DAS and DCS are great because they give us continuous temperature measurements all the way from the top of the well down to the bottom of the perforations.
Having a distributed temperature measurement in carbon capture and storage really helps Perenco to understand the phase of the fluid that they have, whether it's in liquid or gas. So as they inject and it's travelling down the wellbore, they've got this distributed temperature profile along the length.
So using the fibre as a receiver is brilliant, but it's localised around the well, and so we'll only actually be able to see 200-300 metres away from the well.
So the specific questions are what's happening to the fluid when it goes into the reservoir. How is the plume expanding? How is it moving? How fast is it moving? So we need to find a new technique which can track the plume as it moves further from the wellbore. That's why we're going to use Spotlight.
This is waste management. This is not a resources business. So we need to have solutions that are cost effective, that are light and agile to put in place so that we can increase safety and trust in the CCS industry.
What we've developed is a kind of virtual smoke detector of the subsurface. And once a spot is detecting something that is anomalic, then we trigger an alarm to our client.
Last year, when we was a monitoring solution for the Green Sand project on the Danish coast. And that was a huge success towards regulation to show them what we can monitor thanks to such an agile solution.
The Lehman gas field was a great storage for gas. It will be great for CO2 as well, and the measurement, monitoring and verification system we put in place will ensure that's the case.
We are building trust and safety for the CCS industry.
Monitoring, measurement and verification is taking the pulse of our newborn baby.
And I'm confident that we've selected a good programme that will tell us exactly what we need to know.